In this video, we're going to learn again the conditions under which an object will sink or float, but it's in terms of density. Till now, we understood that whenever you have an object in a fluid, it will experience two kind of forces. mg, that is mass of the object, into acceleration due to gravity, and the buoyant force. And the net force would be mg minus fp, provided we take downward direction to be positive. So depending on these two values, the object will sink, float, or move up. All this we have seen. Now we will need to answer the same in terms of density. So up front, I'll give you guys the answer. Density of the object, if it's more than density of the fluid, what happens? The object will sink. If it's less than, it will float. Okay, so this is something that we have to keep in mind. Right? Now, the technical aspect. So one thing is, yes, this is not as per your syllabus, it's not required in terms of writing, it's not required in terms of writing, not that you need not understand it. You need to understand it, but you need not memorize it. That's what I mean. Okay, guys. So let's see the reason behind it. Let's try to understand the concept behind it. Now, I have an object whose mass is MO and volume is VO and density is rho O. Okay, so your net force will be MO into G and minus FP, and this is MO into G. I just converted with a subscript O so as to make sense, like to indicate that this is the object. I'll consider the fluid to be of density rho F. Okay, guys. Mass and volume, we can't decide on that. We don't need it per se. Okay, so let me express this too in terms of its density and volume and all of that. So MO into G is quite simple. Mass is given by, let me write it over here. Density is given by mass by volume. So we have mass is equal to density into volume. So this is density of the object into volume of the object into acceleration due to gravity. Agree? Right? Next thing is we have FP. FP is nothing but your buoyant force. That is equal to the weight of the fluid displaced. Weight of the fluid displaced. Now, how do you figure out the weight of the fluid displaced? One thing is, obviously it has to be mass of the fluid into acceleration due to gravity. That we agree. And mass is given by density of the fluid into volume of something into G. But volume of what? Container? No, right? It is displaced water we are talking about. How much water will get displaced as and when we dip an object into the water? It depends on the volume of the object. If it's completely immersed, it will be equal to volume of the object. Okay, so we'll take it as VO again. Again, I'm not going to all the possible cases. That will be too much for you guys. I hope you guys understood why this is VO. Because we are talking about displaced. So displaced water or fluid will be equal to VO. That is the object immersed. Is it not? So if the object is immersed, so there will be some rise in water. This rise in water will be equal to what? Will be equal to volume of the object. Agree? That's all. So this is your complete diagram. Now all we have to do is substitute it over here. So the net force, therefore the net force is equal to rho F minus V naught into G. Oh no, this is rho naught V naught into G minus rho F V naught into G. And now your basic maths. What is common between these two? Yes, please do tell, I can hear. Just try telling, I can hear. Yes, you guys are right. P naught into G is there. What else is left out? Rho naught minus or plus? Minus, right? Rho F. So basically this is constant. Is it not? This is constant. So basically F net is proportional to the difference in rho and rho F. It's dependent on this. So basically if the fluid, let me actually change it. I want it to be object density more than object density equal to and object density less than. So if the object density is more than that, equal to, and object density less than, it would be better. Now if the object density is more than that of the fluid density, what happens? The F net would be a positive value. So that would mean that you have the F net to be in the downward direction, is it not? Because we are taking down as positive direction, right? Remember? So it will, yes, sink. Agree? Next, if they are equal, what happens? F net will be equal to 0. So wherever you keep the object, it will be there. You keep it over there, it will be at that place. So it can float also. Float or sink or whatever it is. It just stay over there. It will be at rest basically. Wherever you keep it. Okay, yes. Now, when it is less. So what happens? When this is lesser than that, obviously negative number is bigger than the small positive number in terms of magnitude. So this will be a negative number, which means it will get pushed up. Right? So it will move up. Is it not? So basically this will rise up. Got it? So this is your technical explanation, a mathematical explanation. I hope you guys understood. See, simple. If the density of the object is more than density of the fluid, it will sink. If the density of the object is less than density of the fluid, it will float. As simple as that. Okay, this is all you have to remember. But yeah, understanding this will help you guys. Okay guys, so see to that you understand all of it. There are quite a few different cases. What if it's not completely submerged and all of that? That is too much to handle now for you guys. This is good enough. So now pause. You need to know all of this. You need to memorize the left one. You need to understand basically. And right one you guys have to copy everything. So please pause. And here we are using Newton's first law and the second law. Based on that only you'll be able to conclude all of this.